The Fermi Paradox is the question of why we haven't heard from any extraterrestrial species. The Milky Way has had billions of years to produce civilizations, so where is everybody? You can turn this question around and ask, given that we have not heard from any other species, what does this silence tell us? Well, the authors of a new paper just crunched the numbers and arrived at a slightly horrifying conclusion. The starting point in all discussions about the Fermi paradox is the Drake equation. That's an estimate for the number of actively communicating technological civilizations in our galaxy. The estimate comes from multiplying a bunch of factors, like how many suitable planets exist, how often life begins, how often intelligence evolves, how often it becomes technological, and then you multiply by how long such a civilization lasts. The authors of the new paper now instead ask, given that we have not yet detected any signals from other civilizations, how long does a civilization last on the average? They plug in the best current numbers we have for the number of planets in habitable zones and so on. Then they calculate how long civilizations persist, and the result is about 5,000 years. Yes, that's right. They say put in our estimates for the other numbers and you have to conclude that civilizations only keep up their space signaling activity for a few thousand years. If they're right, we may currently be in what historians will later call the final season. They also give a second, more observationally flavored argument. Electromagnetic signals cross the galaxy in about 100,000 years, so if civilizations last longer than this and broadcast detectably for a meaningful fraction of that time, we should have seen something by now. So this estimate is slightly more optimistic, but still it's rather depressing. Why might this be the case? What could be the reason why technological civilizations go dark so quickly? Scientists have proposed basically three different reasons. The first is self-inflicted extinction or near extinction. That might be war, accidentally released pandemics, or environmental destruction that eventually erodes the capability of the species to survive at high technological standard. I think that this problem almost certainly befalls a lot of civilizations. They just fail to grow beyond a certain level of complexity. The second possibility is that there is some sort of external risk factor that we don't know of. Maybe supernovae explosions are much more frequent and more fatal than we thought. Maybe tiny black holes exist after all and eat up more stars than we thought, though I think this is unlikely. The third possible explanation is that civilizations survive, but they lose interest in space exploration. They spend all their time in virtual reality, or they have crossed over to a post-scarcity economy and can't be bothered lifting a finger if they have fingers. Of course, the problem might actually appear earlier. It seems that somewhere between having a habitable planet and having a truly interstellar civilization, there's a step that's so hard that almost no species completes it. This has been dubbed the Great Filter by Robin Hanson. The Great Filter might be because the origin of life is so unlikely. Personally, I think that's not the case. Indeed, in the past years, we've seen that complex chemical cycles that lead to reproduction seem to actually be quite common. However, the Great Filter might come at a later stage. The issue might be that for a species to reach a high level of technological sophistication, its members must be intelligent enough to coordinate their actions. As I said in a recent video, I doubt that humans are intelligent enough to jump that bar unless possibly we manage to use artificially intelligent systems to our advantage. In any case, what are we to make of this somewhat depressing paper? First of all, it must be said that the authors use optimistic values for the other parameters in the Drake equation. They take, for example, a large number of Earth-like habitable planets in the Milky Way, around 1 million, and they take the probability that such a planet produces a technological civilization to be close to 1. It's only then that you get the pessimistic constraints on the survival of a technological civilization. Personally, I think that these values are close to the correct ones. The point where I disagree with the authors is simply the question of what such a technological civilization would be communicating with. The authors, as pretty much everyone else, assume that technological civilizations would, of course, communicate with electromagnetic signals that we can measure. But I strongly doubt that we have yet developed the technology that an advanced species would be using confusing. I think it's possible to communicate faster than the speed of light. And of course, if that's possible, that's what the aliens use to signal. We could be sitting right in the middle of a cosmic broadband stream and wouldn't know, because no one on this planet believes faster than light signaling is even possible. I give this paper a 5 out of 10 rating on the bullshit meter. It's not wrong, but the authors do once again miss the obvious explanation for the silence, which is that we have not yet developed the right technology to receive the signals. And somewhere out there, an alien scientist is currently giving a lecture titled The Earth Paradox. Why haven't they answered?